Hi everyone, welcome to another video about medical devices, and today we are going to break down IEC 60601, what it is, and we're going to cover this international standard and what it pretty much defines the safety in medical devices. If you're a field service engineer, you've probably heard this term thrown around at one point. You may have heard it from LinkedIn or IEC 60601. But what does it really mean for us in the field and what every field service engineer should know? Let's find out. So I just want you to imagine this. Imagine you're maintaining a defibrillator in a hospital, right? It looks fine from the outside, no cracks, nothing. But actually, internally, inside, a leakage current issue could actually shock the patient if they touch it, if there's a live part of it. And essentially, standards like IEC 60601 exist to stop that from happening. By definition, IEC 60601 is the international standard that defines how medical electrical equipment must be designed and tested to make sure it is safe and effective for us to use. This is a globally recognized standard. And so if a device doesn't comply, it doesn't get to become on the market. So this is used worldwide, globally. Why does it matter? So this isn't just signing a paper. IEC 60601 protects patients. It guides manufacturers. It reassures regulators and helps us engineer to do our jobs safely. So what standard covers IEC 60601? The key areas of the standard is mainly electrical safety. So essentially, when you have a Rigel or a Fluke, you see IEC 60601 electrical safety testing built already into the device. And it covers everything from the electrical leakage all the way to the grounding, and also the mechanical hazards of the device, and also radiation exposure. And even when alarms perform when they should. What does it mean for us as field service engineers? So when we install, maintain, or repair equipment, we're not just fixing a machine. We're making sure it continues to meet the IEC 60601 standard. That means testing the leakage currents, checking the grounding, and spotting risk that could actually remove the device out of compliance. For example, when I was servicing an infusion pump, I might run a leakage current test. And if that fails, that pump can't go back to clinical use until it's compliant. So that's IEC 60601 in action. So it kind of protects patients behind the scenes. So a few practical habits that we could always check is always check for the grounding. We could always test the insulation. We could verify that alarms trigger as expected. And whenever you log the job with the compliance logs, make sure it's always organized. And these small checks makes a big difference. What is the future of IEC 60601? So IEC 60601, I believe, won't remain static. It's going to change. And what these changes will include updates covering wireless communication, software safety, and even cybersecurity. So for us engineers, staying ahead of these changes keep our skills relevant and valuable. So IEC 60601 is more than regulation. For us as field service engineers, is a framework that turns us from simple fixers into making sure patients are safe. I know, guys, it's a short video, and if you found this breakdown helpful, make sure to hit the like and subscribe, and perhaps drop a comment if you want me to cover other standards in the future.